At this point, we're talking about lower travelling speeds, lower traffic flow, but we have to pay special attention to the fact that these are going to include people running their everyday lives. So children playing in the street, people out running, cyclists, you'll have parked cars potentially blocking your view. All these things have to be considered. Hello and welcome along to this Let's Talk Light session by Thorn. The road to better lighting, your route mapped out. My name is Daniel Pars. I am the National Account Manager in the UK Public Lighting team. If you have any questions after the presentation, please feel free to drop me an email. My email is daniel.pars@zumtobelgroup.com. This session is the second in a 5-part series. We've already had session 1 presented by Martin Thompson, which was key considerations and top tips. We have session 3 to follow, which is introducing the RPEC optic lighting system. This will be presented by Peter Thorns and Maxime Perdue. We then have 2 further sessions, which will be presented by Waldemar Becker. This is Zaga, Be Ready, Be Future-Proofed, and Urbasense, the outdoor lighting control system. We're kicking off with major roads, traffic routes. This type of road, we have mixed vehicle use, wherever this is cars, buses, van drivers, truck drivers, all of which need to be considered, and all of these vehicles will be travelling at high speeds. Typically, you will see column heights of 8 to 12 meters on a major traffic route. Some examples of some column configurations on the left-hand side here. Twin central, which would be often used for dual carriageways, where you have columns centrally positioned with twin arm brackets lighting either side. Alternatively, you have opposite arrangement columns, where you have columns on either side of the dual carriageway. The key part for any road lighting scheme, but in particularly for major roads, is how do you determine the most appropriate lighting class? This is done by assessing the road in terms of traffic flow, speed of the vehicles, whether it's mixed use, are there pedestrians, are there cyclists, are there footpaths? All of these are key factors, and all of them deserve special attention. So in this particular example, on the right-hand side, you can clearly see we have crossings, we have pedestrians, we have the major traffic routes. You can look at these 2 areas separately. So you can have one luminaire lighting the traffic route, and you can also have an additional luminaire at the back of the column to light the footpath. And both of those, you can use 2 different lighting classes. So you may use an M class for the traffic route, and then an appropriate alternative class, a P class, for example, to light the footpath. Minor roads. So at this point, we're still talking about traffic routes. Although compared to a major road, you will have a lower traffic flow, lower travelling speed, but you've still got all the same types of vehicles and also pedestrian use. So due to the lower traffic flow, you would therefore select a lower lighting class by comparison. There are some additional considerations to be made. Typically, this could be in a more rural location rather than, let's say, a city centre. So you may need to also consider the additional environmental impacts that you may have with your lighting scheme. And as you can see from this picture here, we've got the surrounding areas which are very rural compared to the previous picture, which was more city centre based. Okay, so for minor roads, you would typically have a column height of 5 to 8 meters. You'd have single lane usage rather than dual carriageway, and you would possibly also have a footpath or a cycle path. As you can also see from this example, you'll also have rural considerations to be made. So starting with the road, we're looking for a lighting class that would be appropriate for the traffic flow and the speed of that road, which, as I've said, would be lower compared to a major road. And you also have the consideration for the people using the footpath and the cyclists using the footpath. You may want to add into this point considerations for facial recognition so that people feel safe. This can be done through selecting luminaires with a good color rendering. And you also have the additional opportunity to light the footpath with an additional luminaire, which you can see in this example here. Conflict areas. Conflict areas, you have all of the vehicles that we've already spoken about, traveling at relatively high speeds, all coming into one area from different directions. Now, for that reason, you can imagine that the awareness and the alertness required for the drivers and the users is therefore required to be of a higher level. And because the alertness level is increased, the lighting level should therefore be increased. Now, what this means within the standards is that the conflict zone or the roundabout, junction, whatever it might be, should be lit to one lighting class higher than the highest approach road. So if you have an M2 class road, this would lead to a C1 class conflict zone. You must pay special attention for the exits and the access areas, and you could even consider using a higher color temperature in combination with a higher light level. The combination of these two things will give you an all-round, more alert picture for the drivers approaching the zone. The example that you can see here is a typical layout. Columns will be positioned around the outside of the conflict zone. Residential roads. So at this point, we're introducing more everyday life into the equation. This can be in a city centre, in a residential area, such as a housing estate. So as you can imagine, at this point, we're talking about lower travelling speeds, lower traffic flow, but we have to pay special attention to the fact that these are going to include people running their everyday lives. So children playing in the street, people out running, again, cyclists, you'll have parked cars, potentially blocking your view, pets, all these things have to be considered. Two examples that we can see here. In other areas of the continent outside of the UK, catenary style lighting, it could be quite common, particularly in the Nordics. It's a very efficient way of lighting a street. In more commonly, particularly in the UK and other areas of Europe, you would see the example on the right. So it's a very typical scene. You've got houses, you've got cars, you've got pedestrians. So at this point, not only are you selecting the right class for the road and for the users of the road, but you have to pay special consideration to the residents. This can be for security reasons, so they feel safe in their home environment, but also we have to consider light trespass. Obviously, people's windows, people's private property, they don't want unnecessary obtrusive light spill going onto their properties. All of these things have to be considered. Now, at this point, you are more likely to be at a relatively low level, let's say a P4 class or a P5 class, between 3 and 5 lux average, so a significantly lower level than what you'd expect to see on a traffic route. And again, that goes back to the fact that you've got lower traffic speeds and lower traffic volume. Pedestrian crossings. So the most important part of a pedestrian crossing is that you have to alert the driver to its existence. So they have to be aware in advance that there is a crossing coming up. Whether that is in a city centre or a rural location, the same applies. Essentially, you want that crossing to be as safe at night as it would be in the day. There's some special techniques in order to achieve this. We have the use of double asymmetric optics either side of the crossing. The position of the columns is very important to create that positive contrast for the pedestrian. Within the calculation, we are looking at vertical illuminance. Therefore, we are lighting the person, and that is to give that advance warning to a driver approaching that crossing that somebody is either on the crossing or about to enter that crossing. Typical example would be a 5 or 6 meter column, as I said, with a double asymmetric optic. The light levels should be at a higher level than the approach road, and you may also consider a higher CCT, color temperature, than the approach road. So for example, if the approach road is 3000 Kelvin, you may choose to move up to a 4000 Kelvin light source for the crossing, just to differentiate it from the road itself. Additional measures can be using additional signals just to highlight that crossing. Bridges. Now with bridges, in terms of lighting the road, the same applies to the other types of road we've already looked at. You're looking to light that road in a safe way to the appropriate lighting level. But there are some additional considerations when it comes to lighting a bridge, and that is you have to highlight the extremities of the bridge in terms of the width and in terms of the height. This will potentially highlight any hazards for the drivers. On the left-hand side, we have a comparison of a conventional lighting scheme using columns versus a lower mounted option. Now, a conventional lighting scheme would be, as with other roads, using columns, particularly 8 meter columns, 10 meter columns, 25 to 35 meters apart. Now, one thing to consider is, first of all, will they fit on the bridge? How are you going to fit them? It might not be physically possible due to the design of the bridge. Other things to consider are, what is the bridge traveling over? So for example, if it is a bridge in a city centre, this may be traveling over a residential area, for example. So if you put an 8 meter column or a 10 meter column on top of a bridge that's already 10 meters in the air, effectively you've got a luminaire 20 meters in the air, which is going to create spill light and obtrusive light outside of the bridge that could potentially have a negative impact on the people around you. An alternative to that could be a river where the authority, for whatever reason, might not want to light the river and only light the road. So you have an option here of a low mounting option, which is at 0.9 meters, which means the light distribution is below the eye line of the incoming traffic, below the eye line of the user. This can be achieved through Thorn's flat beam technology in the Aorus luminaire. Now, what this gives you is increased control in terms of your obtrusive light, your glare, and also contribution to sky glow, because the light is concentrated on exactly where it needs to go at a very low level. We're now moving on to some examples of some of our road lighting products. Kicking off with Bizarro Pro. This is a high performance, high quality luminaire that has the full capability to light all the roads we have spoken about so far. So whether it's a residential road or a major road, the product is available in 2 body sizes ranging from 12 LEDs all the way up to 72 LEDs, giving you that full range and capability to light whatever the class may be, up to potentially M2. The luminaire itself has some key design features that are, let's say, installer friendly. That is an important part of any product. The product is accessed from the top without the use of tools. Tilting technology not only allows for the product to be tilted in an upward plane, but also a negative plane. This can be useful in cases where you are installing the luminaire onto an existing bracket that may have a 5 degree or a 10 degree tilt, but you don't want the luminaire itself to be in a position of 5 or 10 degrees without having to change the bracket. So in that case, you have the ability to essentially minus the luminaire. So if the degrees is set at a 10 because of the bracket, the luminaire can be brought back down to 0. This helps you achieve your classes in terms of your glare classes, and also takes into consideration reduction of upward light output. Another example of products within our range is Bizarro. Now this luminaire is particularly designed for the residential applications. It's a smaller, lighter weight product where the residential sizes are split into 2 bodies. This can be useful. In one particular example would be the weight. So in some cases, you could be putting the luminaire onto a pole bracket, or some sort of bracket that is unable to take a certain weight, maybe because of its age. Whereas this luminaire gives you that ability to put on a very, very lightweight luminaire while still maintaining the performance that you need, as with Visaro Pro. At this point, I just want to highlight that all of our luminaires are ready to connect. The industry is very much moving towards this type of technology, Zarga-based technology, sensor-ready, system-ready. There's lots of different terminology that people will use. Essentially, it means that the product is ready to connect to any system or sensor that you may want to use. You can install multiple sensors on multiple sockets, and all of our Zarga devices are D4I certified. In terms of controls, Thorn offers a wide range of lighting control solutions, whether we're talking about remote and wireless control via our UrbaSense control system. I've already touched on Zarga. You can also have standalone systems where you don't have a full control system. You have a standalone system that is either attached to the column or built within the luminaire. So one option is MoveView, which is essentially motion detection. So if you use a footpath as an example, the light will only come on as it senses movement and the presence of either a pedestrian or a cyclist. After they have moved on, the lighting would either then dim back down or even turn off. A bi-power switch is a very simple way of increasing or decreasing your light output without the use of external controls. All of our outdoor products are with our best-in-class RPEC optical system. This is an in-house optical development. This is a topic that will be covered by Peter and by Maxime in a later session. Something that we take very, very seriously within Thorn is corrosion resistance. Essentially, this is making the products fit for purpose for the environment that they're going into. Now, the easiest way to do that is to design them for the harshest environment. So typically that would be a coastal environment with a high saline content. So all of our luminaires, as standard, have a C5 class in accordance with ISO 9223. And what this means is that the product off the production line is designed to be in a very, very harsh environment. You might not need it to be in that environment, but you've got that safety net. There's also question marks as to what is coastal. Some people class it as the promenade in a coastal town. Other people class coastal as 5-10 kilometers from the coast. It's a little bit subjective, and therefore, to give us that complete comfort, all of our products are designed for the harshest environment, and we do that by using the best possible aluminium. This is ENAC 44300, which has a very low copper content, which copper is one of the main ingredients that leads to corrosion. In addition, and another important point to make, is that this C5 class not only applies to the body, the aluminium body, and it also applies to the external fastenings. Any installer will know if they have to go back to a luminaire to try and remove it years down the line, it's the external fastenings that will either corrode or completely break down, and therefore it's very difficult to adjust that luminaire or remove that luminaire. So the C5 class is the body and the external fastenings, which we believe is quite a unique offer. Another thing that we take very seriously within Thorn is the environmental impacts of our schemes. There are various ways that we can minimise that impact through the use of controls, whether that's dimming, trimming, or potentially adding sensors so that the light is only on at the most appropriate times. We also have the option of light shields. This can be externally fitted, retrofitted light shields, or you also have the option of internal light shields, which are actually built into the optical system itself. Color temperature is a hot topic. The industry has moved already from cool white to neutral white to warm white. Potentially this story is going to continue. Thorn are very much on board with this conversation, and we believe it is the right thing to consider the right color temperature for the right application. Because of that, we have developed two new technologies. First being Night Tune. Now what Night Tune offers is a combination of two different color temperature LEDs within one luminaire. So within this example, you have 2200 Kelvin LEDs and also 4000 Kelvin LEDs. And the light is actually mixed. So when both LED configurations are on together, you have a mixed cluster of LEDs producing a mixed color temperature. In this example, you could be looking at 3000 Kelvin whilst both are on. And that might be the most appropriate color temperature during the earlier hours when you still have cars on the road, people on the streets. In line with your lighting class, you have a color temperature that is appropriate for the type of use. As you get later into the evening, there's less cars on the road, people are in their homes. So at that point, you can question whether you still need to maintain that same color temperature. Particularly late at night is when nocturnal animals come into play and ecosystems within the local area. Most of this goes on without us noticing, because it's when we're asleep. So if we're asleep, why does the street need to be lit as if it's still busy? So at this point, we can reduce the color temperature by essentially switching off the 4000 Kelvin LEDs. So this does two things. It saves you energy because half of the LEDs are no longer on, so you have an energy saving benefit, but you also have only the 2200 Kelvin LEDs in play. Now, nocturnal animals much prefer color temperatures towards the red end of the spectrum. It has less impact on their traveling patterns and their general way of life. And what we can do is later on in the night or in the early hours of the morning, when people start to wake up, go to work, go about their day, we can then switch back on those 4000 Kelvin LEDs to give you a higher light level and maybe a more appropriate color temperature for the type of use. So that's Night Tune. Another technology that we have developed is variable light distribution. Now what this means is you've got two different light distributions within one luminaire. This can also be used in combination with different color temperatures. So in the example on screen, you can see that you have one of the optics pointing at the road with, let's say, a 4000 Kelvin. And then you have the footpath, which would be for pedestrians or cyclists, which could be 3000 Kelvin or 2200 Kelvin. It's about selecting the right color temperature for the right application, for the type of use. And the combination of using two different optics within one luminaire gives you the advantage of not necessarily needing two luminaires to do the same job. Now, all of these can be used in combination together. So you could have night tune and variable light distribution. Additionally, at this point, you could even talk about adding sensors. So you've got night tune looking after the color temperature, the appropriate light level. You've got variable light distribution, giving you the right distribution for the right application at the right time. And then you could add sensors into the equation. So for example, the footpath on this particular scheme could maybe only be lit when it's needed. Well, thank you for listening. If you do have any questions, please drop me an email at daniel.pars@zoomtogroup.com.